two, one.
Hi, good afternoon, good evening, and good morning to those who are in US. Thank you for joining. My name is Ravi Chunduru. I'm an associate fellow at Verizon, working in the space of virtual network services domain. As you all know, we are in the middle of a digital era. DevOps is playing a crucial role in this era. Many enterprises have adopted SDN and NFV-based solutions. They deployed SD-WANs, software-defined branches, cloud-based services, to name a few. Still, there is a gap between network and DevOps. So in my presentation today, we're going to walk through the need for network transformation and how at Verizon we have overcome this problem by coming up with programmable networks or network as a service. And finally, we'll walk through a few screenshots of our portal. So enterprises which are practicing agile digital transformation, they are doing rapid application lifecycle management. If you take an example, retail business with 1,000 stores. So they are wanting to roll out new services, new applications to their customers rapidly. So they want to launch new applications and to save costs, they will want to move the applications between data centers to public cloud or vice versa. And they want to even terminate those applications at a rapid pace. So in our example of retail business, let's say the enterprise decided to roll out a new checkout application in a data center. Then they have to figure out which stores are needing this application access. And they will have to go into that each and every store. As a network engineer, one has to identify the devices and then provide access to that new application in the firewall, in the SD-WANs, and in all the devices that needs to be programmed. They would go and configure that. And in case of application migration, they have to go and identify which stores or accessing that application and go and change, remap the configurations. And let's say in firewall, they'll have to remap to a new IP address and port for that particular rule, and in SD-WAN as well. And if enterprises sunsetting the application, they'll have to identify which stores are accessing that point of sale application. And then they'll have to go exactly which firewall rule was created for that application and terminate that rule, close that firewall port. And even the SD-WAN configuration, they'll have to go through that similar cycle. So for a scale of 1,000 stores, if a network engineer is spending 1 hour in one store for 1,000 stores, it is 1,000 hours. It means a lot of time is spent to make the changes across the network. And that is adding a lot of process overhead and time, which is a big impediment to digital transformation. And now let's take a look at the change management in our managed services domain space. So the enterprise customer would request a change, and the change is going to a service desk, and managed service provider would assign a network engineer for that task. And that network engineer will analyze what is requested and then schedule the required changes. And then when it is time, the network engineer is going to apply the configuration onto the device. They will have to verify, confirm it is all working, and then finally notify back to the requester. So as you can see that there is a big cycle of process. There are many humans involved, and it is a error prone. If the analysis is not done properly, the configuration would go wrong and it would go multiple iterations. And it's a huge process overhead. It might take any time like a week or more, depending on the type of change requested. And expect what else can happen when we are trying to change a access rule between user to application. and especially when there are multiple network devices involved in the path from user to application, then we'll have to request a change for every network device involved in the path, be it firewall, be it SD-WAN, LAN, WLAN, and the list can go on. So the change request goes into multiple network function domains, and that further adds some more time spent to work to make that changes across the network, and it's a much more process overhead. So at Verizon, we have looked at this problem statement. We have seen the complexity involved in the configuring the devices, especially identifying which exact rule needs to be modified. If a mistake done in firewall could lead to multiple security vulnerabilities. So it is super important that they, network engineers do a precise analysis and do exact changes, verify, and then complete it. So we wanted to automate as much as possible and make a simple interface available for our customers. And that's where we have come out with co-managed services. And this services we have launched back in November 2019, along with our full managed services that have been existing. Co-management is a flavor of both customer managed and full management. In case of full management, Verizon takes care of entire thing. The change request goes to Verizon and Verizon does the changes. In case of co-management, Verizon still does majority of the product lifecycle, be it product installation, activation, the customer specific configurations, troubleshooting, audit reports, all of that. Along with it, customer gets to have control in the policies. In the customer specific configurations, they get to control it, configure it. So this method of this product of ours, co-management, enables our enterprise customers to make changes into their network in real time, and the flexibility and control lies with them. And by the way, this co-management solution is powered by our in-house built intent-based solution to further simplify the complexity involved in configuring the path right from user to application. So this slide here describes a bit about how that intent engine is built. Intent is here essentially defining a relation between a user to application, and how that access between user to application is processed and defined by a set of network functions. So as a network engineer or as an enterprise customer themselves, they can come onto our self-services portal, or they can use the Digital Connect platform through our APIs. They can configure the changes. They can configure the intent-based policy rules. And our intent engine is going to process that intents and figures out automatically which devices need the changes. It automatically figures out what are the impacted devices and what exact configuration needs to be pushed into that devices. It translates that intents to from high-level English words of users and applications to the low-level device-specific parameters like IPs and ports. And at the same time, by its vendor-agnostic characteristics, it will figure out what is the the target device it is talking to, and then convert that intent business rules, which are English type of words, into a device-specific configuration and push it onto the devices. And this is all done without any human touch. And it is done in real time. So those are the key blocks in enabling the digital transformation for the enterprises. That is where how we try to bridge the gap between the network and DevOps. When DevOps is acting on some events of application lifecycle management, our intent engine is enabling and making sure the network also reacts at the equal pace along with how DevOps is handling application lifecycle management. So now let's take a look at how the business logic of change management is going to work with our co-management services. So as usual, in this case, the customer, not just network engineer, even the customer can submit changes onto our portal or through APIs, of course, through our Digital Connect platform. they can set new business rules or modify the business elements related to the devices. And when the change is submitted onto our portal or through the APIs, our system is going to record the change requested. It's going to persist that in our databases to ensure a future auditing or troubleshooting and debugging purposes. One can look back those change records and determine what happened, what exactly happened. So and rest of the process that was in the traditional world is fully automated. The validation, making sure the configuration is reliably applied onto the devices, and checking back as a feedback loop, what is my expected configuration and what is actually running in the devices. It validates, and after it is done, it is going to give success to the callers. And at the same time, we have this a fault tolerant mechanism. If the device is not reachable at that time, it is going to wait till the device is reachable and healthy, and it's going to set that configuration requested change. And there are possibilities of human errors. Even though we have automated this entire cycle, if our operations goes into the device and makes any manual changes directly into the device, which is leading to conflict with what is expected to run and what is exactly running in the device. We do the diff every now and then onto the device and find out if any conflict arises. We generate a report for the users and for our internal operations to figure out what exactly happened and then make corrections. So this way, we have ensured that there are no human errors, and the change can be done instantaneously in real time to meet the needs of DevOps and digital transformation. And now going to the next slide here, the same concepts are applied onto all the network domains. In the sense, when user is accessing an application, the entire path that and the devices involved in that path are fully or automatically identified, and the device are configured with the right configuration sets as needed. So this fully eliminates and fulfills the gap, eliminates the gap between the network and DevOps. So let's take a look at one of the digital transformation use case and how it is going to work with our new model. And I have picked up a application migration in this case. So again, let's imagine this is a retail business use case, and there's a point of sale application that is launched into a data center. The intent here is the enterprise wants to save the cost, so they're going to migrate this point of sale application from data center to public cloud. So now let's go through that, what's going to happen in the traditional approach. So DevOps is going to migrate the application from data center to public cloud. And they are going to notify the network engineers, telling them that, yes, this application has migrated to the public cloud, and this is the a new IP and port of that application. Can you handle the network? And network engineer is going to study that change, what is exactly needed, which stores are really accessing this application, and what devices, what network functions are situated in that store. Some stores might have just firewall, some might have SD-WAN and firewall and WAN optimization. It could be multiple combinations. So they'll have to find out each and every impacted store, identify the device, identify the exact configuration rule in case of firewall, and the exact SD-WAN policy rule for SD-WANs. So they will have to make precise changes into the configurations of each and every network function and remap that configuration to the new IP and port. And they have to repeat this cycle across all the impacted sites or stores. So if the same example, if it is going to take 1 hour to make changes in each store, depending on the number of stores, it can take more than a week or several weeks. And also some configurations need to be done in the data centers and in the public cloud as well, right? And in case of firewall, you have to close the open firewall ports for the point of sale app. and then open up firewall rules in case of the public cloud. So all these changes, analysis, and making exact identification of the devices and network policies does take a lot of time. And now let's take a look at how we're going to do that with the intent-based approach. The same setup here. So the DevOps is going to migrate the migrate that point of sale application from data center to public cloud. And they are going to add an additional step in their existing DevOps pipeline, be it Jenkins or CI/CD pipeline. They can add an additional step of automation to invoke our Digital Connect API call, indicating that application has migrated. So what they're going to put up in their request call, so they're going to say that point of sale application, and this has migrated to a new location, which is public cloud, and they're going to indicate that this is a new IP and port. That is it. And our Verizon Digital Connect platform, which is powered by intent-based policy engine, is going to react to that event. It's going to process, identify what exactly happened, and then determine which devices are impacted, of course, which stores and which devices are impacted, and then identify exact configuration change that needs to be done, and what vendor is implementing the network function. It automatically figures out all these aspects and then reconfigures the firewall rules or SD-WAN configurations in all those impacted stores. Mapping that destination to this new IP and port. This happens everything in an automatic fashion. There is no human touch. And this is actually enabling us to go towards the autonomous network with automation, with our ability to reconfigure the devices without any human touch is leading towards autonomous networks. And similarly, rest of the use cases of digital transformation, when new applications are being launched or when applications are being terminated, our intent-based policy engine can accept API calls from the customer's DevOps, and then make changes automatically without any human touch. So that's how our solution, co-managed services, is empowering enterprises in their journey towards digital transformation and really becoming agile, bridging the gap between network and DevOps. So the total time taken is close to 1 hour. It's actually real time if the device is not reachable and things like that, as we are implementing the reliability. So it might take close to 1 hour to make changes across all the stores here. So finally, I will present a few screenshots of our portal here. You can see this is a self-services portal, and our customers can get onto this portal, make changes manually, or they can use our APIs through Digital Connect platform. Here, this is showing a customer with a few locations. As you can see, there are 3 with the intent labels assigned to all of the locations, which determines what configuration needs to be processed for the devices in that location. And this screenshot here, it's showing us a simple set of business rules set up in this portal here for this demo customer. And you could see that the users access to applications at a very high level towards the managers accessing social media. They will have an all-day access and type of network function processing needed through SD-WAN, which is bulk data, and set a quality of service profile. And essentially, it is capturing a relation between user to application, how that relation should be processed by network functions. And you see that there are no there are no low-level details like IPs and ports. Everything is English type of words where you create that relation between elements. And this screenshot here is showing us how we maintain the revision history of every change. Our system is going to auto increment the versions for every change made in portal or in the APIs. And imagine a customer having a big fat finger. They set up something, and after a few days, they realized that configuration is not good, or something went wrong. And they can look at the insights of what they have configured and what is exactly running in the device, as well as they will have ability to look back, what is my known good state of configuration. If they don't have much time to rectify that configuration issue, they can easily go back to a known good state by looking at this revision history, and looking by clicking that plus button on towards the right, they can look in what was the difference between current configuration and this version of the configuration. When they feel that this is the known good state of configuration, by looking at changelog and configuration details, they can click on the revert button, and entire configuration can be restored to a known good state without a further human touch. And all the network devices would be running that version specific configuration state automatically. So this is another screenshot here, which is showing the insights onto a particular location and for a particular network function. Here you would see, out of all the business rules that are set up in the system, this particular device is running this particular set of applicable intents. And these applicable intents are auto-selected based on the user groups and applications. So there is no human touch involved or configuration needed at a site or a device level. The system takes care of generating applicable intents from global set of rules and configures the devices from there on. So with that, we come to end of the presentation. Thank you, and let me know if you have any questions.